Muy bien, vamos a con la última de las presentaciones, con lo que no hace falta, creo que me presente a mí mismo.
This is the last speaker, the last presentation. Actually, I'm going to speak. And basically, I don't need to introduce myself, but I'll keep it very brief, I promise, so that we can finish by the time we were allocated. And I will begin. I will be talking to you about the simulation of OBS networks in order to assess remote assistance services. Now, this presentation is based on prior projects carried out by the Broadband Network and Services Group at the Polytechnical University in Catalonia. And we are trying to identify the best technologies in optical networks that can have an application for massive transportation of data or in the application of other type of users, such as, for instance, this type of assistance-based networks. What is the working scenario? It's actually quite different, although the optical networks have been applied for this type of massive data movement in basic grids, such as, for instance, telephonical networks or other type of national operators. But there's also other type of actions carried out in these assistance networks, because there are some patterns, equivalent patterns that are quite significant. 2 years ago, I gave a presentation in this very same conference about this, and the material is at your disposal. So as you can see, in our environment, we have a set of users, a group of users that will somehow be monitored. We will listen and basically monitor these users. They might not be restrained to some specific group, but in their buildings or their facilities, there will be different sensors set up throughout, well, as I said, buildings on the streets, in specific locations, and there will be a control center receiving the results of those signals, and if necessary, that signal can be transferred to some kind of urgent emergency services, the type of services that they might need in those cases. And that's the goal of my presentation. I'll be talking to you about the type of network infrastructure that is needed. Setting up any type of network infrastructure is, of course, an expensive action. And as we have seen in this morning's keynote speech by the colleague that has talked to us about this need to do simulations and how to optimize sensors to achieve higher performance, well, that's exactly what we want to do with this type of remote assistance services. And we identified a pool of problems that are quite similar to the ones dealing with data transfer networks. For instance, a typical problem would be an optical environment or medium, because they use fiber optics, and the data are faster than the processing ability of many switches because of the electronic conversion that takes place. However, in the case of remote assistance services, given that there are many small sensors sending out these small packages, the longitude, the length is actually shorter. Therefore, there's a similar situation in which the switches can try to process this data at a faster speed because the packages are smaller. So we developed a simulator carried out in the lab, and this simulator uses scripts mostly. So they're not too user-friendly, only necessary, the competent technicians can handle it, but it allows us to simulate the network scenario for this type of switch optic communication by grouping together at the ends of the network these packages of data, but in huge packages. There's a control package that somehow paves the way towards the end user at the network. And once that path has been established, then the flashes of data can proceed on that track, on that path. And then we can count the number of packages that are running the network. What is the structure of the simulator? I've done my best to minimize the number of figures, encoded figures, and just to show some icons, some more somehow friendlier images in order to render this presentation a little bit more lively. But as you can see, there are several blocks. The first one allows us to define accurately any network. Then we have a simulation module, then another one for analysis, yet a different module that allows us to store all of this information, and then finally another one that will visualize, that will display the results. So I'm going to break all of this down and tell you exactly the type of components that make up every single one of these modules. The first one, as I said, is called definition. It has several blocks included in it. First of all, it allows us to define the topology of an OPS network, and we can establish the number of elements that make up that network. Let me also draw your attention to the fact that we're not defining a typical TCP/IP network, because all of these networks that will be added to the topology can only be characterized by its own traffic profile. So we don't need to add a different complexity and degree to the simulator than what it already has. And we have these elements that are needed. First, the boundary node, the nodes that interact with the TCP/IP networks, which on top of it allow us to aggregate all of these packages and to send them, to issue them to the other end of the network. Then the core nodes that switch packages from one link to another, and then finally, of course, the link of the network in the case of fiber optics. Then we also have different structures that help us analyze the type of TCP/IP traffic that will be added up to the boundary node on top of the OPS traffic, and that can be part of the OPS network, either on boundary nodes or even on core nodes. And once we have the whole topology, element, and traffic, we need to define the routing, planning, or aggregation protocols that will be used. Now, regarding the routing, well, they are the ones that allow us to discover a path between two ends of a network. They can be either dynamic or static. Now, as far as the planning goes, these are the mechanisms that will be used within the network whenever there's congestion or jam or any type of conflict. What are the type of bursts that will be prioritized? We'll be able to store them, or we'll have to roll them out. And finally, the aggregation protocols going beyond the boundary nodes. How can we add up all of these packages, TCP/IP smaller packages? Well, all of these is based on scripts, of course. Once we have the whole parameters for the network, then we can simulate this. And all of these modules, of course, are correlated with the consecutive parts of the system. We have modules that allow us to cover the whole network at large, then modules for every single element in the network, either the links, because a link is not only a channel with incoming and outgoing information, but also the delay of propagation is considered, or even, ensuingly, we'll be able to deal with any possible inconvenience or problems. In the case of fiber optics, we might be able to be inclined to think that there are no problems, but there might appear some in the future. This might happen in terms of communication between the links. So if that happens, we would no longer be defining traffic or OPS or TCP/IP, but rather would be talking about generators. And they will be using statistical values. So mean measurements within the packages, times, average delays that might apply, and different types of distribution to create different types of traffic, either uniformous traffic, exponentially increasing traffic with different measurements, with different sizes, with general mean sizes that are mostly larger or mostly smaller, focusing on a specific value. So on the basis of all of those data, we can come up with the necessary parameters for any type of traffic, and then the generators can apply all of this traffic throughout the simulation. So we would define not only the features, the elements for every node link in traffic, but on top of it, a generator can be used, for instance, fixing the number of seconds or the number of packages that are necessary. And in this pseudo-random fashion, they would be generated. It's one of the possible functions. They can also be conducted randomly, as long as there's a seed planted in the computer. And finally, how are these packages going to use the routing, planning, and aggregation protocols? They will be behaving as need be. There's an interesting item on this presentation, because the result, the outcome of all of these analyses is traffic, OPS traffic, because what we are creating is a whole bunch of data that can be used. So many that we decided to use two different structures. On the one side, we have a provisional or temporal traffic structure, which is used when simulating over the long run, needless to say. And this is a data structure with a very big size, with a very large size, and that has been a problem in terms of memory. The whole memory has been used, and that might be a problem. So we need to improve those structures, because at